Hi, I'm Sharon Macklis at IDG Communications, here with a special episode of Do More with R, How to Set Up Your System for Python. It's special because I've got a guest today, Serdar Yergolab, InfoWorld's Python expert and host of the InfoWorld Dev with Serdar video series. He's here to help answer questions we R users might have when installing and configuring Python for RStudio. So let's get to it. If you're working locally, the Reticulate R package has an easy Python install command, install_miniconda. If you run that, you should see a response something like this. R is running commands to install Python, install some Python packages, and create a virtual environment. So what's happening here?
Well, what you're seeing here is RStudio installing a version of Python called Conda, or Anaconda. Conda is the short version of it, which is a version of Python that's packaged specifically for math and stats users. It comes with a great many of the things that are normally installed separately, such as NumPy and Matplotlib, but are all aggregated together into a single package. And if you install this way using Conda, they're all pre-installed for you. So you don't have to do any additional work to get up and running with a lot of the things that our users would most want out of Python.
Sounds like a good way to go. Now, I notice at the bottom here, in addition to the packages, it says to activate this environment, use and code, and to deactivate, use code. What's that about?
Well, environments in Python are a way to take, basically they're like sub-installations of a Python interpreter. They're a way to take an installation of a Python interpreter and segregate it from other installations so that you can work on a specific project in a given installation without having the packages that need to be installed in that installation conflicting with other packages and other installations. Virtual environment will bring to mind probably things like virtual machines, and that's not quite the same thing, but there's the same general idea of keeping things isolated. So if you're working on more than one Python project at a time, and you need different packages or different versions of the same packages, this is a good way to keep each of those projects from stepping on each other's toes. So it's a good idea that they're recommending for you to use an environment, because otherwise things could get hairy very quickly.
Yeah, it sounds like there's a similar R environment package, but I don't think it's used quite as often as Python users use virtual environments. Now, this is the super easy way to install, but just to let us see step by step what's actually going on for those who want to understand, and also for those who use the RStudio Professional RS Connect product, there's a step-by-step way to do this that RStudio recommends. And you can see the URL here at the bottom, and they've got a whole bunch of steps. So let's just go through and see what we would do if we were going to be doing it manually. So step one, not surprisingly, would be install Python. Now we had that done for us with the Miniconda, but if we had to choose between python.org or Anaconda, what would you suggest?
Depends on the work case. And if you're doing math and stats in an environment where Anaconda is already in use by other people, then it makes sense to work with Anaconda, because again, everything's installed for you and it's set up for you, and there's very little fiddling involved. The downside with using Anaconda is that it's kind of its own thing. If you use that version of Python, it's best to use only that version of Python. If you use the python.org version, it's very bare. It doesn't come with anything pre-installed, but it's also, it doesn't try to take things over quite as aggressively as the Anaconda version does. So I would say it depends on what's already in use in your environment. It depends on what other people in your organization are already using. If they're already using Anaconda, go with that. If they're just using the regular python.org version, go with that.
There's another choice we have here. There's the 3.x or the 2.x. Which should we choose?
Oh, the old debate. Yes. At this point, you only want to use version 3. The only reason that you would ever use any of the version 2s is if you are trying to use a project that requires compatibility with the 2.x line. But 2.x has been obsolete for a very long time. It's not used anymore, or rather, it's not supported anymore. There's still some places where it is in use, but it's really not a good idea to keep using it if you're already using it. And absolutely don't start new projects with it. Start new projects using Python 3.8. You can use Python 3.9 if you choose, but there are some packages that are not fully compatible with Python 3.9 yet. So Python 3.8 is generally your safest choice.
Great, good to know. sounds a little bit like Windows XP.
Excellent analogy, unfortunately.
Okay, the next step here is to create a virtual environment in your RStudio project. The Miniconda installation did that for us, but if we needed to do it manually, these are the steps. And you load the reticulate library, and then you run this in a console, not the R console, but a system console. Next, we want to activate our Python environment. Now, that was the instructions we had at the bottom of the slide here, if we're using the Miniconda, but if we're not, these would be the instructions. The RStudio instructions say this, but make sure that this bin is actually the path to your Python virtual environment, because on Windows, it's likely to be different. Then once you're finished, you can test it by typing in the console which Python. And I think that tells us which is the default, Serdar, is that it?
That tells us which version of Python will be run when you type Python from the console. It's also worth noting here that when you activate a virtual environment, it's activated for the duration of the time that console session is open. So if you activate it in a console and then you close that console, that environment is not activated anymore. The activation is specific to a console session.
Good to know. So even if we have RStudio open and switch to another project in another directory and then switch back, we need to activate again.
Yes. You need to add each one separately too.
Okay, step 4 is a familiar one. Install the Python packages we want, but instead of install.packages like we would do with R, we're using this pip function and install, and then a list of the packages we want to do. Is that pretty much what's happening here?
Pretty much. When you use pip install, that is the installer that is provided with the regular python.org version of Python. Anaconda has its own installer called Conda, as appropriately enough, which is designed, again, specifically to work in that environment. So you'll want to use the installer that is appropriate for the version of the edition of Python that you're working with.
That's quite a bit different from R, where everybody uses the same install.packages.
Yeah. This is why Anaconda is kind of unusual in that respect, and that, you know, if you choose to use it, you have to adapt to a number of different Anaconda specific ways of doing things. So it can be a little jarring for people who are just coming from the regular Python distributions.
If you're using Miniconda, these packages, which are among the most popular for data people, will already be installed, however. And
It's
probably the ones we wanted, if with Miniconda, we would already have, but this is in case, you know, you're doing it from scratch.
correct.
So the last step is actually in R. We want to configure Reticulate in our R console. So we want to make sure that Reticulate is loaded already with library. The instructions here say to do it this way, but on Windows, it may be something like this, where instead of /bin, it would be /scripts and then python.exe. But again, if you did the Miniconda installation, this will already be done for you. And it's another reason why, unless you're working with RStudio Connect or something where you really need to do this manually, having the built-in way to do it is quite handy. So now we've done all this, and it's time to actually try to run some Python code. So how would we do that in RStudio? So there are a couple of different ways to do this. You can do it in an R Markdown document with a Python code chunk. You can do it right within your R code using the Reticulate's pyrunstring function. You can source a separate file with the Reticulate R command pyrun file. And you can do it in an RStudio console, not the R console, the system console terminal, the usual Python way. And now we're going to try and run some code that Serdar wrote for us. And here is what we're trying to do. So let me restart the R session so we start from scratch. And let's start by doing it the Python way. So I'm going to go, this is our R console, but if you look at the bottom left here, I can go to a system terminal right within RStudio. And I would go Python space, and then the name of the file, which is conwayslife.py. Okay, notice there's no parentheses, there's no quotation marks around the file name like we would do with a source in R. And while this is running, maybe you can tell us what it's doing.
Okay, well, this is actually a mathematical game. invented by the mathematician John Conway. And it's a simulation of a colony of cells living and dying and reproducing. And one of the reasons I decided to use this as a demo is because the back end of it is actually quite a bit of matrix math. And if we use Python's NumPy, we can perform this matrix math very quickly. And we can also plug into the matrix objects that are created by Python and inspect them using R. So if you scroll back up in the terminal a little bit, you can see how the cells have been growing and changing and mutating over the course of the 20 generations that I had running the simulation.
So that's pure Python. Now let's see if we can
actually, strictly speaking, it's Python plus the NumPy library, which is written in C. But yeah, that's the basic idea. That's just Python. It's not R yet.
Okay, so here is your code. So we've got here where you're using the NumPy library, and then your functions, and then running it. But now we can, instead of running it in the terminal, we can actually run it within RStudio. So I would do that. I'd load my reticulate library, and now I'm going to use this pyrunfile command. And now I am actually using parentheses and the quotation marks because that's our syntax. And it seems to have done the same thing here. And now I can actually access the Python variables with this py and then the $, and then you can see all the variables that are here. So if I just try to run this, I don't think anything happens. No, actually it does. Who knew? But if I store it in an R variable, I can actually then use RStudio to open it up and take a look at what's here. And it's just a logical matrix of trues and
Booleans,
false.
yeah. This is the same matrix that is in the Python object, and we've just plugged straight into it, and we're able to inspect it and work with it here. And this is true for pretty much any variable that will be exposed to the Python script, regardless of whether or not it was created by NumPy. I believe you should also be able to connect to other, standard Python objects like ints and floats and so forth.
Great. Well, thanks so much for coming by and helping to explain Python for us, our users.
Glad to help.
That's it for this episode. Thanks for watching. For more R tips, head to the Do More with R page at bit.ly/domorewithR, all lowercase except for the R. You can also find the Do More with R playlist on YouTube's IDG Tech Talk channel, where you can subscribe so you never miss an episode. And for Python tips, check out the Dev with Serdar series in the same channel. Hope to see you next time. Stay healthy and safe, everyone.